All right, so 1.7. Okay. Yep. Yeah, so you may just need to open the e-textbook, okay, or just PowerPoint lecture slide, okay, but this should be fine, okay. So 1.7, so all right, so 1.7 is about the linear inequality, okay. Linear inequality. So what's a linear inequality? A linear inequality with one variable, okay. So I'm sorry, one variable, I'm sorry, yeah, one variable. So here, objective, okay, let me write the objective first. Okay. So first one, yeah, we're gonna learn the inner verse, first one. Okay, so remember that what's inner verse? Inner verse is for example, is like this, 1, 2 is a parenthesis. Again, this is not ordered pair. Okay, do not confuse with the ordered pair. Okay, this is all that means the set of all numbers between 1 and 2. Okay, or there's this one bracket. Okay, 2, 3, something like this, and then maybe you see negative infinity to 0, something like this. So that here infinity, you see that infinity, that's the infinity symbol. It means the huge number that we cannot imagine. Okay, so this negative infinity is yeah, negative huge number. Okay, something like this. Okay, so then bracket and 3, 5, something like this, comma 5. Okay, yeah. So we're gonna study these inner notation, the parenthesis and the bracket. Okay, see parenthesis and the bracket. These are called the inner notation. So we're gonna study the meaning of inner notations and why do we need to study inner notation. Okay, so and then what kind of inner uh there are. Okay, so and then next one, yeah, so we need to study how to solve linear inequality. Okay, so what's a linear inequality? Linear inequality is this. um the Think about this. Linear equation with one variable, that was ax plus b equals 0. So that's a standard form of linear equation, right? So instead of equal sign, we replace less than or equals. Okay, less than, that means less than or equal. That this one means the equal sign. Okay, so some textbook use that symbol, some textbook use that symbol. Okay, but either one just fine. But I prefer to use this one. Okay, less than or equals, greater than, and greater than or equals, is or something like this. Okay, so yeah, do not confuse with this one as 7. Okay, this is not 7, this is inequality. Okay, so there are 4 inequalities, right? So instead of equal sign, there one of them is involved, then that's going to be linear inequality. So let's see example like this: 2x yeah plus 7 is less than 0, something like this. Okay, or other example is negative 3x plus 1 is greater than or equals yeah, just 1, something like this. Okay, all right. So next one, that's the last objectives. Oh no, just there's one more. Okay, so third one is the we're gonna study compound inequality. Okay, so compound inequality means that 2 linear inequalities are coupled. Okay, so but yeah, we'll see. Okay, so next one, we're gonna study linear inequality with absolute value. with absolute value. Okay, so example is this. See a, for example, 2x plus 3 is less than 5. Okay, example, something like this. So see the unequal absolute value is involved here, right? Okay, give me a second. Yeah, so now, okay, so back to the linear inequality. Okay, so right here, look at this. So let's take a look at it. 2x plus 7 is less than 0. Okay, then uh, so the how can he solve the inequality? It means that I want to find out a solution set satisfying this inequality. Okay, so what kind of a value for x makes that inequality, that linear inequality, to be true? Okay, if x is for example, when you plug in 1 into x, you're gonna get 2 times 1 plus 7, which is 9, but 9 is not less than 0. So number, real number 1 cannot be answer, cannot be a solution, right? So to do that, um, we solve the that inequality like what we did in linear equations. So it means that we need to isolate x. Okay. So, but you may just wonder that, okay, I thought I thought we have to study inverse first, right? Yeah, I'll cover this one, but to cover this, to understand why do we need this, we have to solve the just one linear inequality problems. Okay, so let me solve this one. So remember that in linear equation with one variable, when you solve this to isolate x, we apply the property of equality, right? So when you do something on one side, you have to do the same thing the other side. So likewise here, when you do something, when you just, for example, when you subtract 7 and then when you divide by 2, you have to do the same thing the other side too, okay? But the only different thing is this. The only different thing from the linear equations, when you multiply or divide by negative number, that inequality will be reversed. Okay, keep in mind this. I'll show you. So here's an example. We're doing solving problem one, right? Example one. So example one. Okay, example one. So 2x plus 7 is less than 0, right? So I want to isolate x. Okay, so keep in mind this. The goal is to find our solution set. Okay, so I'll subtract 7. Okay, subtract 7. So we got 2x is less than negative 7, right? And then we divide by 2. This is exactly the same as what we did in linear equation with one variable, right? So now then we're gonna get x is less than negative 7 over 2, right? Okay, so but what if the sign of the number 2 is a negative? It was a negative right there, for example, okay, for instance, so negative, negative, then you have to divide by negative 2, right? So when you divide by negative number, or when you multiply by negative number in inequality, that you have to reverse the inequality. Okay, that inequality will be reversed to greater. Okay, okay. So we're gonna give a specific example later. Okay, so just keep in mind this. Okay, now we got this, but can you say that this is answer? um yeah, so uh this cannot be final answer, but we can say this is just we can say just simplify the inequality. Okay, so it's a kind of simplified version of the original inequality. Okay, so we cannot say this is the answer. Okay, but how can you describe all of numbers? I mean, look at this. X is less than negative 7 over 2. It means that any numbers less than negative 7 over 2 should be solution, right? So how can you describe the set of such a numbers in mathematics? So there are two ways to describe that solution set. The first one is what? Using the number line. Okay, it goes to negative infinity and then negative infinity. So when you work the homework set and quiz, then you see a lot of number line in 1.7 homework set. Okay, so he's maybe 0 is right there, and then negative 7/2 right there. Okay, negative 7/2. Okay, then all the numbers less than negative 7/2 must be solution, right? So here's a question then. Let me give me a second. Oh yeah, so like this, right? Okay. But x, you see that, look at the inequality. There is no equal sign. So it means that x cannot be negative 7/2. It means that negative 7/2 cannot be answered. Should be excluded. How can you express that one here in mathematics? And then this was a problem, right? And the second problem is this. Drawing a number line and then doing this is not really convenient. Okay, so that's what we need the inverse. Okay, so inverse. So that's what we have to study inverse. Okay, so instead of the describing solution set using number line, we wanna express the solution set using inverse notation. So the second way to write the solution set in mathematics using inverse notation. Okay, so the inverse there is yeah, briefly I just mentioned that the two type of inverse, just bracket, parenthesis and the bracket, right? See that the parenthesis and bracket. So parenthesis, okay, that's called the open inverse. Okay, what's the open inverse means? Open inverse means that the n number, for example, let me explain this one by using example 1, 2. It means that the n number 1 and 2 are not included. Okay, and then parenthesis is used as a symbol of open inverse. So then open inverse 1, 2 means that the set of all numbers between 1 and 2, but n number 1 and 2 are not included. Keep in mind this. And then, but what if we want to include the n number? Then we use a bracket, and then this bracket is the symbol of closed inverse. Okay, so there are two types of open and closed, but yeah, we said two types of inverse, right? Open and closed. But here's a question. Sometimes we may need to, include the left n number, but not include the right n number. Then we use this one. Close 1, open 2. Sometimes then we may need to include one left n number. I mean, left and we don't include left n number that we use open, and then we should include the right n number. Okay, so these two type of inverse are called the half open inverse or half closed inverse. Okay, but I prefer to use I prefer to call these are as half open inverse. Okay, so now then back to these problems. Okay, so you see that x is less than negative 7/2. So any number less than negative 7/2 must be answered. Then how can you write the solution set using inverse notation? It's going to be negative infinity to, oh, by the way, back to the inverse notation. Keep in mind this, always left n number must be less than right n number. Okay, so there is no such a inverse notation. For example, 2 comma negative 10, something like this. For example, there is no such inverse notation. Why? Because left number is not less than negative 10. So keep in mind this, left number must be less than the right n number. Okay, all right. So from the negative infinity to comma and then negative 7/2, and then negative 7/2 must be excluded, right, from the solution set. So we got to use open. Okay, and the negative infinity positive infinity, or just call it just infinity. Okay, infinity or negative infinity. We if you get the infinity or negative infinity as n number, but for the negative infinity it must be used as left n number, and then in positive infinity must be used the right n number. Okay, so if you get the infinity or negative infinity as n number, you have to use open. Okay, so it means that we cannot include the negative infinity or positive infinity, okay, in the solution set. Okay, why? Because negative infinity, positive infinity are what? Symbol, not an actual number. Okay, so we gotta use the closing number, not opening number. Okay, so if you get this kind of expression, close negative infinity to something, for example 10, right, that's not the right expression. Okay, or you say 10 to close 10 to positive infinity close right there. That's a wrong expression. There is no such expression. Okay, so okay, so now inverse, back to the inverse here. So inverse. Okay, so we studied open and close, right? Open and close, right? So key minus open means that open inverse means that n number is included, and the close means that uh, open means n number is not included. And the close means that n number is included. So what circumstance we use open? So you see you get the less than or equals or greater than or equals. So the when you see linear inequality problems and then inequality is involved equal sign, then oh, not this one, sorry. Then means e equal sign is not involved. Okay, it's just less than or greater. Then not always, but most of case, you may have to use open inverse. Okay, and then when you see linear inequality problems and then you see equal sign is involved in inequality, so less than or equals or greater than or equals, then close inverse probably okay possibly okay positively I mean positively the close inverse is should be involved. Okay, so now next one, the bounded unbounded inverse. Okay, bounded unbounded inverse. All right, so unbounded, okay, bounded, unbounded. Let's explain about unbounded. So in this, like this example right there, so negative infinity or infinity is involved in the inverse, then those inverses are called the unbounded inverse. Okay, so let me see. There are four type of unbounded inverse we can think about. Four cases. Okay, so negative infinity comma a. Okay, so open. Second one, negative infinity comma a close. Third one, a to infinity. Okay, last one, close inverse a to infinity. Okay, all right. So here's a is number line. Okay, is a negative infinity. Okay, so negative infinity through the a. Okay, and then negative infinity to the a and close. Then we use a bracket right there. Close, I mean, and the open. Okay, but when you work the online homework, then they don't just express the open and close and they don't put the open inner symbol in the here. Okay, over the arrow sign. Okay, so but I just I just prefer to put the parenthesis over the arrow sign. Okay, so now a to infinity. Here's a, and then here's infinity. So open. This is A, they close, open. Okay. There was a bounded. The bounded means that both left and the right end numbers are real numbers. Okay. So we can think about the four cases, just fully open, kind of open. And the next one, half open, right? And then this is half open, another half open, and then close. Right. Okay. Let me skip drawing the number line. You can see those bounded, unbounded, four cases for each in the textbook. Okay. You see the table. So in this case, keep in mind this. We assume that A is less than B. Okay. All right. So now then, see, now back to the example right there. Let's see like textbook. Okay. So to see some examples about this. Okay. So, okay, let's see example 2. Okay. So here, example 2 in the textbook, page 162. Okay. So question is this, solve the this one, negative 3x minus 9 is less than 0. Okay. So I'll show you the textbook. Give me a second. So here, example 2, solving a linear inequality. So solve negative 3x minus 9 is less than 0. Write the solution set in interval notation and graph it. Okay, let's figure out this. Okay, and then give me a second. So you can see that you see the property of the inequality right there. So that is similar to the property of equality, what we learned in section 1.1. Okay, so the only different thing is this. So see, the second property, you see that when you as the second one third property. So when you multiply or divide by a negative number, see the inequality is reversed. You see that? Okay. Keep in mind this. That was actually less than, right? But change to the grade then. Okay. Okay. So keep in mind this. Okay. So back to example 2. Okay. Let me solve it here. So we add 9, right? So we add 9. So we're going to negative 3x and then less than 9, right? And then we divide by negative 3, right? So when you divide by a negative number, what are you going to do? I told you, we saw that the inequality will be reversed. So we're going to get x is greater than negative 3. Okay, that's not the end, I told you. So we have to express solution set, which is set all numbers which is greater than negative 3 using interval notation. So let me just figure out the solution set in the number line, okay? Negative infinity to infinity. And then here's a negative 3, okay? So greater than, there is no equal sign in inequality, then we gotta use open number because n number negative 3 should not be included in the solution set. So we use open, okay? Open to, well, let's say open to infinity. So we're gonna get the, what, unbounded number, right? So case 3, unbounded number, right? So the answer is what? Open negative 3 to infinity. Okay, so that's the answer. Okay, so now next one, example 3 in textbook. Okay, so example 3. All right, so same question as of example 2, but inequality given is a little bit complicated than that one. So 1/2 x minus 3 is greater than y equals 1/4 x plus 2. Okay, so what are you gonna do? First, we have to put all of x terms together to isolate x, okay? So I'm gonna subtract 1/4 x on both sides. Keep in mind this, when you add or subtract the negative number, doesn't mean that you have to reverse inequality, okay? Well, only if you divide or multiply by a negative number, you have to reverse the inequality, okay? So the now then this those two guys gone, and then we're gonna combine those two guys, right? And then let me add a 3, okay? Add 3, add 3, because so that we remove all the constants from the left hand side. So 1/2 minus 1/4 x gonna be what? 1/4 x, right? If you don't get it, look at this. So 1/2, okay? Oh, sorry, it's kind of blurry, right? Okay, excuse me. All right, so 1/2 minus 1/4, then what are you gonna do? X, all right? Then we have to find the LCD, right? Oh, still again. Give me a second. So then the LCD gonna be what? 4, right? So 1/2 gonna be 2/4, right? Nothing but 2/4. So 2/4 minus 1/4 is 1/4. So we got 1/4 x. Okay, and then it's greater than or equals and 5, right? Because 2 plus 3 is 5. Okay, so then we multiply by 4. Okay, so we multiply by 4, then we're gonna get this: x is greater than or equals 20. Okay, so now we just simplify inequality. Okay, so in mathematics, we say that this one, that inequality is equivalent to that inequality. So equivalent means that in 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 terms of equation or inequality, two equations or two inequality have the same solution set. Then we say that two equations are equivalent, or two inequalities, linear inequality or whatever inequalities are equivalent. Okay, so then let me draw a number line right there. So negative infinity and the infinity. Okay, so here's a 20. So x is greater than or equals 20. Then we use a bracket, right? Closing number, I mean, to infinity, right? Okay. So the answer must be. Oh, so in this problem, so we got the unbounded interval. So close 20 to infinity, right? Now here's a question: that what circumstance we're gonna get the a bounded interval as a solution? So when you solve the compounded inequality, then usually most of cases you will get bounded interval as a solution set. Okay, so now we'll see a compound inequality. So compound inequality is okay. So from here you have to listen carefully. Okay, so compound inequality is the main part of this section 1.7. Okay, so maybe a little bit hard to understand that. So uh, give me a second. See right there. Okay, so we actually I introduced the four cases of bounded interval, right? Open interval a comma b, close interval a comma b, and the half open interval a comma b right there. So the other way to express that these solution set, these interval, is using the set notation. You see a curly bracket. Using the curly bracket, we can express the all the numbers between a and b as like this. Okay, for each cases. So What I mean is what I mean. Okay, you see this one. So please, yeah, please be familiar with these these symbols. Okay, notations. Okay, so because you may see these notation in the online homework, so please keep in mind this. So that means nothing but closing number AB because equal sign in both inequalities, right? Okay, so these the bottom, I mean two the set from the bottom means half open. Okay, top one means the opening number A comma B. Okay, so just look at that. Now the compound inequality. So I'll cover the objective 3 compound inequality. All right, so okay, so before going over the how to solve the two compound inequalities, we need to understand the two terminologies. Okay, so the first one is intersection. The other one is union. Okay, so intersection means this. Intersection of, for example, set A and B, or you can say A intersect B. Okay, so A, B. What does it mean? Set A, B are just a set of numbers. Okay, and it means that A, B are integers. Okay, so these you can consider A, B as integer. Okay, okay, or we can say sets. Any set, just set. What is set? Set is just a group of numbers satisfying certain equation or inequality or just certain rule. Okay, so A, B are integers. So now that is the this one is the set. So intersection of set A and B is the set. Okay, A intersect B. So that is a symbol of the intersection. Okay. Keep in mind this. So sometimes this is called the cap. Okay. So okay, or A cap B, or officially A intersect B. So it's called A B. Okay, keep in mind this. So what does that mean? So A intersection set of A and B in the set A intersect B. That means this is the set of all numbers. Okay, belong to both A and B. Okay, that means okay, it means the set of all numbers belong to both. Okay, that's important. Both A and B. Okay, so let me write down the union next page. Okay, so what does that mean? A and B. Example. Let's say example. So think about this. Let's say A is the negative 7, 5. And let's say B is I don't know, maybe open and 0, 2. 0, 2, 0, 10. Okay, let's see. Okay, then let me plot those two integer in the number line. Okay, so negative infinity and then infinity. So here's a negative 7, and then here's a 0 maybe, and then 5 is right here, and here's a 10. Oh, oops, let's say this is 10. Sorry, here's a 5. Okay, so now then what? A, give me a second. I need other marker, maybe. Let's see. Give me a second. So now then, A is a negative 7 to 5, which is this, right? Negative 7 to 5. And then B is what? 0 to 10 is this, right? 0 to 10. So uh, A is opening number, right? Open bounded number. Right? The B is also open bounded number too, right? So now then A intersect B. That means what? The set of all numbers belong to both A and B. So what numbers belong to both A and B? Here, right? So it's the overlapping part. So the overlapping part of the inner A and B must be intersection of A and B, right? So A intersect B is going to be what? 0 to open 0, comma 5, open number. Okay. Now then, you may guess that what union means. Union is the union of A and B means that the set of all numbers belong to either A or B. Okay, it's kind of sum of all numbers. Like kind of, okay. I mean, kind of the list of all numbers belong to either A and B. Okay, so union. The second one, union. Union. Oops, union of set A and B. Okay, this is denoted by a cup B. Okay, yes. Yeah, mathematicians says looks like a cup, so they say just A cup B. But actually, this is symbol of union. A symbol of union. Keep in mind this, and then A union. This is called the A union B. A union B. Okay. Oops. Sorry. Right. So the A union B means the what? The set of all numbers belong to either A and B. Okay. So back to the you got it. Okay. So you got it. So back to the example right there. So let's find out A union B, which means that the set of all numbers belong to either A and B. So then we pretty much uh, shade all of the region, all of the area between negative 7 to 10, right? Okay. So it's a negative 7, comma 10. That's gonna be A union B. Okay. I know here. I know. So I mean, I know we have to think about lots of different cases, right? So what if A and B2 set doesn't have overlapping part? I mean, common part don't have common part. Then what happened to the A intersect B? Okay. So what if either A and B are unbounded number? Okay, I mean negative infinity or infinity are involved. What happened? So let's see. So now next one. So let's see. Let's study more different cases of examples. Okay, to better understand the intersection and union. Okay. So then, by the way, so why do we need to study the intersection and the union? Because when you solve the compound inequalities, so we have to deal with two linear inequalities. That means we're gonna deal with two the solution sets. Okay, so depending on how two linear inequalities are connected, coupled in compound inequality, we may have to find out intersection of two solution set or union of two solution set. That's why we need to study union and intersection first. Okay. So now we're here, back to here. Okay. So the other example. Okay. So first, let's see example in textbook. Okay, that will give you see, yeah. So that's example 4 in textbook page 164. Okay, so let me show the problems. Okay, right here, example 4, intersections and unions of integers. So let A equals 1.1, okay, 1, 5, and then let's say B. Let's say B is half open, 3, 7, and then C is 6, infinity. Okay, so write each of the following sets in interval notation. So first one, A union B. Okay, and then B is A intersect B, and then C, A union C, and then D, A intersect C. Okay. Um, okay. So now, all right. So first one, let's plot the A B and A C. You see that here? We need to figure out the uh, this, you know, what A union B, A intersection B, and then A union C, A intersection B. So let me draw two number line. Okay, so it's negative infinity, negative infinity. Okay, and the positive infinity, positive infinity. So 1, 5. Okay, maybe 1 is right here. 1, let's say here's a 1. Okay, and the 3. Okay, and the 5 and 7. Okay, so 1, 3, 5, and 6. Okay, right here. So 1, 5 is what? So A is this. Open 1, 5, right? Open, right? Then B 3, 7, right? Half open, close, open. This one. Okay. So and then for the second number line, I'm gonna plot the set A and C. Okay. A is open, A to 5. Okay, and then C is 6 to infinity. 6 to infinity. Okay, so infinity right here. Okay. So now we're gonna do. Now we're gonna find out first one A intersection B, A union B, A intersection B in the first number line. Okay. So A union B is gonna be what? The set of all numbers belong to either A or B, right? So since the what A what two intervals are have the common part, okay? So what all numbers between 1 to 7 gonna be answer, right? So this is gonna be open set 1 through the open 7, so 1, 7. Okay, the A intersection B, as you can see that the common part gonna be 3 to 5, close 3, open 5, right? Close 3, open 5. Okay, and then what about A intersection C? So A intersection, this is A, right? This is C. So A intersection C, you see that here two sets are separated, right? Without the common part, so completely separated. In this case, there is no way to express A union C as a one single interval. So A intersection C is just a 1, 5 union, and then 6, infinity open. That's the simplest form of the expression of A intersection A union C. Okay, so give me a second. That really is blurry, right? That works. Hmm. Give me a second. All right, so now next, let's find out A intersection C. So as I told you, what there is no common part between set A and C. So there's gonna be what empty set. I introduced the pi, root letter pi, in class, right? So pi means empty set. Okay, empty set. Okay. So keep in mind this. The key point is the C and D. Okay. So now, give me a second. So let's see another example. So think about this. Let's say A is a negative infinity to what? I don't know, maybe 8, close. And let's say B is the what? Negative 2, close interval, negative 2 comma 8, open. Okay. Let's find out A union B, A intersection B. Okay. So then let me figure out the graph of those two intervals in number line. Okay. So negative infinity to 8 here, right there is negative 2. Okay. 8. So set A is negative infinity to A close, right? And then set B is negative 2 close to infinity, to 8 open it, right? Okay. So now then, let's say this is A, this is B. Okay, what's A union B? So A union B is what? Because can you say that set B belong to set A completely, right? Okay, you see? So you may say that, but you have to carefully take a look at this one. Set A include right and number A, but set B does not include right and number A. That's why we can say that set B is included in set A completely. Okay. So what if a number A is not included in A, and then but number 8 is included in set B? Then we cannot say the set B is in the set A completely. We cannot say that. Okay. So now then A union B gonna be just set A. Okay, because set B is completely belong to set A. Okay. What about A union A intersection B? A intersection B is what? Just B. Okay. So sometimes you may see this kind of the relationship between set A and B. Okay. So keep in mind that. Now we're ready to study compound inequality. So let's see. Compound inequality one. Compound inequality. So this one, um, there are two types of compound inequality. So compound inequality with connector and then compound inequality with connector or. So and means that the intersection. Okay, and the or means that, I mean that doesn't mean the and. If it's two linear inequalities are coupled with and a and, then you gotta use the intersection, and the two linear inequalities are coupled with a connector or, then you gotta use union. Okay, so it's blurry, right? Give me a second. Give me a second. Okay, this is much better. Okay, so over here. Okay, so I know you a little bit abstract, right? So you don't get you don't get the what that means. So let's see example. Okay, so example 5 in textbook. All right, so first one. Question is this: solve each compound inequality. So 2x minus 3 is greater than 5, and 4 minus x is less than or equals 3. So you see that this is linear inequality, this is linear inequality. So two linear inequalities are coupled with the connector end. So it means that then we're gonna find out solution set of each inequalities, and then we're gonna find out the see the end. So we're gonna find out intersection of those two solution set. Okay, so that's the that's what this means. Okay, so yeah, from the first inequality, see we add 3 and divide by 2, right? Then x is greater than 8 over 2, which is 4. Let's do that. Adding 3 divided by 2. So here, when we subtract 4, then we're going to get negative x is less than or equals negative 1, right? And then we multiply by negative 1. Then inequality will be reversed. So we got x is greater than or equals 1. Okay. Now, what are we going to do? So here, we draw the we find out a solution set in integral notation, right? But definitely x is greater than 4. This in solution set of this inequality going to be what? Open 4 to infinity, right? This one close integral 1 to infinity, right? Okay. So now, what happened? Okay. So now then what? 4 to infinity. So here's a 1 right there. It says 4. Then 4 to infinity is this. 4 to infinity, right? Okay. And then 1 to infinity, close 1 to infinity is this. Close 1 to infinity, right? So see, two linear inequalities connected with the end. So we got to find out intersection. Okay, but as you can see that 4 to infinity, that interval is that interval belong to what? The closed interval 1 to infinity. So 4 to infinity, that's going to be a intersection of two solution set. So 4 comma infinity intersect with closed interval 1 comma infinity, that is equal to 4 to infinity. Okay, so that's the answer. Okay, see. So now, next problem. See this B. Okay. So let me solve one more problems. Okay, and then just call it a day. Okay. And then I'm gonna continue. Uh, I'm gonna go over the compound inequality with absolute value next time, and then I'm gonna cover 1.2. Okay. So this is problem B. Okay. So 4 minus 3x less than negative 2, and or 3 times x minus 2 is less than or equals negative 6. So you see that two linear inequalities are coupled with a connector or. So we're gonna find out, here's a strategy, we're gonna find out the solution set of those two linear inequalities, and then we're gonna find the union, of those two solution sets, okay? So we subtract 4, excuse me, so we're gonna get negative 3x is less than negative 6, then divide by negative 3, the inequality will be reversed, okay? So we're gonna get x is greater than 2, okay? And this one, we divide by 3, okay? So we got x minus 2 excuse me, x minus 2 is less than or equals negative 2. And then x is less than or equals what? 0. Excuse me. So then let's figure out the solution set in interval notation. Then here, there's going to be what? Open to infinity. This one going to be negative infinity to 0, close. Okay. I saw that a lot of students made a mistake in here uh when they solve this kind of problems. And then I mean when they find out the solution set in here, they just say 0 to negative infinity and then close. That's a completely wrong expression. Okay, keep in mind this: left number must be less than 0, less than the right hand number. Okay, so number line is right here. Okay, so 2 to infinity is a 0, here's a 2, and the infinity is a negative infinity, right? So 2 to infinity is this. The negative infinity to 0 is this, right? Oh, yeah, let's see, this is closed, right? Then 2, this is open. Okay. Excuse me. So what's the union of two excuse me, union of two solution set? Just negative infinity to 0, close, union, open, 2 to infinity. Because I told you we have seen similar problems in Popper, right? So when two solution set are intervals are completely separated, and then when you find out the union of two sets interval, then we just write two solution set and then connect with union. That's the simplest form. Okay. All right. So let me stop here. Okay. So next time I finish 1.7 and then I'm gonna